Hey everybody, Mrs. Bixler here, and I'm here to talk about section 4.5 from your textbook. And if you look at your textbook, you'll notice that 4.5 talks about absolute value or squared quantities. We're going to talk about the squared quantities later, but we're going to focus right now on absolute value. And this is probably a term that you remember from 6th and 7th grade, but we're going to delve into more detail in this lesson. So first, I want to talk about what absolute value is. So remember, last year you learned that absolute value was the distance that a number was from 0 on the number line. So if I had +5 or -5, they are both 5 units. Those are terrible brackets. Those are both 5 units from 0 on the number line. So I could say that the absolute value of -5 is 5 units from 0. And 5 is also 5 units from 0. So the absolute value is indicated by these little things. And you know what these are called? There are actually a lot of kind of cool mathy names for these, but the one I like the most is pipes. So these pipes indicate to us whatever's inside of the pipes. We are trying to find that distance from 0. So the absolute value of -5 over here on the left is going to be +5, and the absolute value of 5 is going to be, I wrote 0, but you know I meant 5. Duh. Okay, so moving on. You've got that in your head. Good. So now let's scooch on. I want you to pause the video and answer these top 2 problems. All right, so we're back. So hopefully you got that the absolute value of -8 is 8 and the absolute value of 8 is 8, because remember, what comes out of the pipes is going to be positive. Now I want you to try the bottom one. Pause the video and do it. All right, we're back. So hopefully you noticed, well, wait a second. I've got what comes out of here is +8, just like these two. So I know what goes inside has to be positive or negative. So we get 2 values here for x, just like ZPP. We get 2 values for x. X can be +8 or -8. All right. So a little side note though. Do you notice how I'm looking for what goes inside of here? And so there is a number, maybe, whose absolute value is -5? No way, Jose. Remember, what goes inside the pipes, this number could be positive or negative. But what comes out, this has to be positive. So if, let's say I had x on the inside here, right? I don't know what number that is. I know that x is going to be no real solution. There is no real solution. So you can either just write NRS or you can write x equals NRS, even though x doesn't really equal anything. Cool? So this would be no real solution. Whenever you see a negative coming out of the pipes, it's going to be no real solution. All right, moving on. So we talked about x. We talked about absolute value being the distance that a number is from 0, but it really could be the distance of any 2 numbers. Because look what happens. Let's say that I'm 25 years old and you're 10, okay? I know you're not 10, you're like 20, but let's say I'm 25. That's like the most important detail here. All right, so if I'm trying to find the distance between our ages, like how many years apart we are, because of absolute value, because of these pipes, we now have the ability to do that. Because I could do my age minus your age. So look what happens. 25 minus 10 is 15, and the absolute value of 15 is 15. But I could also say, like, all right, well, starting with your age, let's do your age minus my age. Look what happens. 10 minus 25 is -15. And you know you can't be -15 years apart, but because of the pipes, I now have that power. So the absolute value allows us to do basically physical distances between numbers, and it doesn't matter which number you start with. So you could do 100 minus 7 or 7 minus 100. It doesn't matter. You're still going to figure out how many units apart they are because of those pipes. So keeping that in mind, let's look at this problem. So I've got 2 numbers here. I'm trying to find the difference between them, right? And I know that difference between them, I keep saying difference, I mean distance. So physical distance between them is 30 units. So what that means is whatever's inside of these pipes could be +30 units, right? +30 years, or negative 30 years. And look what's inside the pipes. X minus 20. And so all you do here is you set up two equations, just like ZPP. And if we were to solve this up, I'm going to add 20 to both sides. Whoops. So add 20, add 20. I get X equals 50. And on the right-hand side, I'm going to add 20, add 20, and I'm going to get X equals negative 10. Now I want you to pause your video here and I want you to check. And what I mean by check is you're going to plug in these two values for X into this original problem. And I want you to see that if when you put in X or 50 for X or negative 10 for X, that you're going to get out positive 30 out of the pipes. Pause the video and then let's come back together. Okay, we're back. So hopefully you plugged in and you figured out that you're going to get with 50 minus 20 and negative 10 minus 20, you're going to get out positive 30 or negative 30 in our pipes, and we get out 30 no matter what. Fab! Okay, moving on. Pause the video, try this one on your own. Do it! Okay, we're back. So I'm gonna go scoochie, 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 scoochie. So look, see that I've got something within the absolute value and it equals 19. That means this thing within the absolute value could either be positive 19 or negative 19. And then you solved, and you got that X equaled 12 or X equaled negative 26. If that didn't feel good to you, pause this, try it again, and maybe go back to the previous slide. All right, here we go, next one. Now pause the video again, try it. Okay, we're back. So this one, don't be intimidated. We still have something within the pipes that is equal to positive 4. So what you're gonna do is you're gonna set up two equations. So you know that 2x plus 7 equals positive 4, or 2x plus 7 equals negative 4. Solve, 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 and you get x equals negative 3 halves, or x equals negative 11 halves. Now remember, you can leave things as top heavy as long as they're fully reduced. So keeping this in mind, it's kind of weird, right, that we've got x's that are negative, but it's not, because remember, what's inside the pipes could be negative or positive. What matters is that what comes out is positive. Keeping that in mind, what about this one? Can you solve this problem? No, the answer is no. Why? Because something that is inside the pipes, if it comes out, it can never be equal to a negative number. So this is going to be NRS. Remember our side note from a few slides earlier? This is it, right? Whatever comes out of the pipes can never be negative. Okay, last problem. I want you to pause the video and try it. Ooh. Okay, we're back. So hopefully you realized the very first step here is to divide both sides by 3 before you tackle the pipes. So we got to get the 3's out of there, and then you are left with this problem. And then snooze. You know how to do these. You're going to make two equations, solve, 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 and you get x equals 1 or x equals negative 5. You're going to crush the worksheet. Good luck. And if you have any questions, feel free to reach out. I'll talk to you soon. Bye.